Well, we're going to get going. Hello, welcome to Slooh Space Camera, another of our live events to celebrate a month of live astronomy. We're trying to give you a live broadcast every night showing live views of one object or another, and tonight it's going to be Jupiter and its moons. I'm Paul Cox, and as I say, this is Slooh Space Camera. It's best off if you're watching in the Hangout on Google+. It's better to watch on the Slooh homepage because you're going to be able to see the images far better on the homepage. So I do recommend that you go to www.slooh.com and you can take a look at the images there. So this is the second. I'm flying alone. You might see. Pat's not with us tonight. He's having a nice family weekend. It's 3 o'clock in the morning here in the UK, and more importantly, at the Tenerife Observatory, Slooh Observatory, it's 2 o'clock in the morning. So it's dark, and Jupiter has been up now for an hour or so. So we're still looking at it really quite low. It's about 24, 25 degrees above the horizon at the moment. So the image quality isn't fantastic. It will improve as the night goes on, but we are fighting clouds as well tonight. So sometimes we might see some strange colours going over the images, and that's just when passing clouds going over. But we're going to persevere with the live images. And before we go into some of those, and the other thing that we're going to talk about tonight, which I think is really exciting, which is about Galileo Galilei and his discovery of the Galilean Satellites, the moons, and those are the moons that we're going to watch tonight transiting Jupiter. But before we look at that, I just want to say to everybody, this whole month of live astronomy is in support of Slooh's My Sky campaign. Now, you will have seen this already, I expect, but please go to www.slooh.com/mysky. This the My Sky campaign is a new mobile app that we're launching, initially for iOS devices, iPads, like that, but we are also planning an Android app as well in phase 2 of this, and we need your support. We need your support, help develop the app and get it out to everybody. It really, the base point of it is you're going to be able to control from any mobile device the robotic telescopes that we're using tonight to see these live images, and you're going to view kind of a virtual planetarium on your mobile device, and you'll see some icons on it. So for instance, where Jupiter is tonight, you'll see an icon there. You'll be able to click that icon, and that will automatically send off a message to the servers in America, and they will send through a message to the observatory in Tenerife and other observatories, and it will take an image. You'll be controlling the telescopes with a single click. It's going to be really exciting stuff, and we're really looking forward to it. Existing Slooh members also going to be able to upload all of their existing images. So normal Slooh members, they subscribe to the service, they control the telescopes at the Canary Islands Observatory, and they snap pictures and build up these fantastic libraries, and they're going to be able to upload those into this virtual sky. And really what you're doing is you're going to be building your own virtual sky with all of your own images in it, taken live from telescopes in the Canary Islands. So we're really looking forward to it, but we really, really need your support. So we're passionate about scientific outreach. We're passionate about getting astronomy into the hands of everyone to make it accessible. And if you share any of that ambition, then please support the campaign. But now, let's see some live astronomy then, because that's what we're really here for tonight. So I'm just going to switch off my ugly mug and do a screen share, so people in the Hangout will at least be able to see some of the images. But really, I do recommend that we don't say it just to take traffic to the Slooh website. We say view these events on the Slooh homepage, because then you'll see the full quality images, which you really don't get when it's kind of screen shared through the Hangout. Anyway, what are we looking at? Well, for everybody who's on the Slooh homepage, you'll see that there's a round circle in the middle, and inside that round circle is the live image of Jupiter tonight. This one is taken at the moment with our what we call our T2 high mag telescope. That's on top of a volcano in the Canary Islands. It's a high altitude site. Some of the best professional observatories and telescopes are based there, and Slooh are incredibly fortunate to be there. So that's what we're looking at. So what can we see here tonight? Well, we can see immediately that some of the belts on Jupiter are really quite well defined, and you'll also see kind of just above the kind of halfway line of Jupiter a couple of kind of long black dots. Those are called barges. And all of the effects that we're seeing, any feature that you see on Jupiter isn't really kind of on its surface, because its surface is, I've forgotten now how far exactly, but its surface is well within the planet because it's a gas giant. Jupiter is one of the gas giant planets. So what we're seeing is all of these features are in its atmosphere. And it rotates at such a high rate. These storms and equatorial bands push against each other, whipping up these enormous storms and belts from deep inside the planet. And of course, the most famous one, of course, is the Great Red Spot. And we're going to see that coming into view a little bit later on. But have a look at this first image that's coming through at the moment. It starts off with black and white, and then will gradually build in the color. And this is a fantastic image that we're looking at the moment, because we are just seeing the first sign of it's Europa's shadow. So you can see to the left of Jupiter there's a small dot. That small dot is the moon Europa. It's the smallest of the Galilean satellites. It has an icy surface. It possibly has a sea beneath, a liquid sea beneath the surface. So it's quite exciting for astronomers to think, and astrobiologists to think, that it might be a really good place for life to be. But what we're seeing there is if you look at the Jupiter's disk, just at the 7 or 8 o'clock position, you'll see a kind of little nick taken out of Jupiter's disk, and that's Europa's shadow. So the sun's casting its shadow onto Europa, and it's casting the shadow down to the planet, onto the atmosphere. And we can also see there the other moon that we're looking at tonight, and that is Io. And if you look on the bottom dark band of Jupiter, just to the right, you'll see a little white dot. And what we're seeing there is Io. And that's transiting in front of the dark disk, so it's really easy for us to see tonight, which is fantastic news. Io is the innermost moon. It's the most volcanically active body in the whole solar system. We used to think that Earth was the only place that had volcanic activity, but actually, we found that there's a lot more dynamic bodies in the solar system than we initially thought. And so why is Io, this little moon going around Jupiter, why is it so volcanically active? This thing that if you see, I've got a couple of screenshots on some of the graphic channels. So if you press the little arrows at the top to change what you see inside the viewing portal, you'll see I've got a couple of images of Io and Europa there. And Io is yellow, and it's sulfur. That's why it's yellow. And the volcanoes actually aren't spewing out molten lava, but they're shooting out these plumes of sulfur and sulfur dioxide. Because there's not very much gravity, obviously, on such a small body as Io, these plumes of hot sulfur shoot up 300 miles above the surface, and then they fall back down and they coat Io in this sulfur, this gorgeous color, sulfur, coating the entire planet. And because it's so active, the surface is ever changing. So when we first looked at the surface of Io, it's a lot different now, because it's continually having its surface reformed. So it's a fascinating moon. We call it a moon, but actually it's really a satellite. That's how we should call these moons of Jupiter. They're really called satellites. Somebody asked me actually after the last Jupiter show, they had a fantastic question. Don't kids ask the best questions? And this lady's son or daughter, I've forgotten which, but they were watching the last Jupiter show together. And he asked the question, Mummy, why is our moon called the moon? And really, there wasn't very much of an answer to that, because there was this confusion over calling Jupiter's moons and our moon. But of course, when we refer to Jupiter's moons, it's with a small m. When we refer to our moon, it's with a capital M, because it's a proper name. But anyway, properly referred to as the Galilean or Jovian satellites. There are 4 main ones: Callisto, Ganymede, and the 2 that we're seeing tonight, Europa and Io. And there are a multitude of others, and we continue to find them. But the others are, they can be almost large rocks kind of thing, not quite to that extreme, but they're not as major as these first 4. And that goes on to our other subject tonight. So just to remind you what we're seeing on this first view, if you look at what's called the T2 high mag telescope view, we're seeing a full color live image of Jupiter. We're seeing to the left its moon Europa. We're seeing just on the 8 o'clock position of the planetary surface Europa's shadow, and that's going to continue crossing left to right across the planet as we watch tonight. And then the small white dot in the dark band at about the 3 or 4 o'clock position, that's the moon Io. But we're going to click on now, so click the small blue arrow at the top of the page, and it will take us to what we call the T2 wide field view. And this is a telescope which is piggybacked there. Both telescopes are piggybacked on top of each other, so they're both pointing at the same thing at the same time. But this one provides a really wide field of view. So what we're seeing now is the really, really bright dot there, the bright circle there is Jupiter itself. And just to the left of it, we're seeing, in fact, that is probably Ganymede and Callisto tonight. Just having a look. Yes. No, sorry, I'm wrong. The one just to the left of the planet is, of course, Europa, which is what we're looking at, and the one to the far left is Ganymede. So we're only seeing 2 moons at the moment, but later on when we look at this view, we're going to see the 3rd moon. So Io is currently in front of Jupiter, and later on we're going to see it emerge, and it's going to, in this image, it's going to emerge to the right-hand side of Jupiter. But around the same time as it's emerging on the right-hand side, that's when Europa, the little dot that we're seeing close to Jupiter at the moment, that's going to disappear, because that's going to go in front of Jupiter itself. So it's really active, and that's why I love observing Jupiter. It's such a dynamic system to watch, and although I love looking at it through telescopes like Slooh's telescopes, you can also have a fantastic view of it in a normal pair of binoculars. So at the moment, around the same time, so around 2 o'clock in the morning, 3 o'clock in the morning for Northern Hemisphere people, wherever you are, so about 3 o'clock in the morning, if you look to the east, you'll see a very, very bright, what looks like a very, very bright star. And tonight, it's just a handful away from the moon that's coming up just after it. So wherever you see the moon coming up, look slightly above that, and the brightest thing there is going to be Jupiter. Slightly later on in the morning, after the moon's come up, you'll see an incredibly bright object, and that's Venus. But so if you happen to be up at the mad time of 2 or 3 o'clock in the morning, or you get up early for work, and that's going to be all this week, and in fact it's going to get better and better as time goes on, as we go into winter, take a look at that bright star, what looks like the bright star, and you've found Jupiter. Get a pair of binoculars. It can be a kid's pair of binoculars. I've done this with literally a $5 kid's pair of binoculars, and this is what I'm going to talk about with Galileo a little bit later. This is what I find so amazing about this, that a kid's pair of binoculars, you will see the view that we're seeing here in the T2 wide field telescope. It's not going to be as crisp as that, but you will definitely be able to pick out Jupiter. You won't see any detail on Jupiter in a cheap pair of binoculars or a cheap telescope, but you will see these tiny pearls that look like they're on a string on either side of Jupiter, and you're seeing the Galilean satellites, just as Galileo did back in 1610 in his rudimentary telescope. And this view that we're getting from the T2 Wide Field Telescope. Although this telescope is very capable of observing lots of things, and it's got a very expensive scientific CCD camera on the back of it, the actual view when we're looking at something like Jupiter is very comparable to the one that he got through the first telescope that he made. And by the way, that's not the very first telescope that was made, which is a common mistake that's made. But we'll go into that later as well. So that's what we're seeing in this view, and that's what Galileo would have seen over 400 years ago. And I just think that's amazing that we can see now a kid can go outside in the garden with a cheap pair of play binoculars, look up, pointed at Jupiter, and see what Galileo Galilei saw in 1610, 400 years ago. That's amazing. Now, sometimes it's really difficult to hold a pair of binoculars steady, and when you're looking at the higher magnification binoculars you've got, the more important it is to hold them steady. So if you haven't got find a wall or something like that, put your elbows tight into your chest, stick your elbows on the wall, and hold the binoculars really tight to you. If you haven't got a wall, get a broom, turn the broom upside down, so it's standing on its handle, and rest the binoculars on the broom head. That's a really cheap telescope mount, but that just gives you the kind of steady handhold that you'll need, and you will see these beautiful little pearls on either side of Jupiter. So I'm going back. People in the Hangout, they'll only see this on the screen share. People on the home page, you can press these triangles yourself so you can see the other images that I've got coming up tonight. By the way, the clouds are being really, really kind to us tonight. So I'm going on to this next one, and here we go. Here's the first sketch of what we're talking about with Galileo tonight. And these are the sketches, I think, from the 7th of January through to, I've forgotten when, so I won't quote it, but I think it was through to about the 24th or something like that. No, it's the 17th, I believe. So the 7th to the 17th, and he pointed his telescope to Jupiter, and he knew it was a planet, and they knew that it moved against the background of stars, and he pointed it up to Jupiter, and this is what he saw, and this is what he drew. And the first night that he looked at Jupiter on the 7th of January 1610, 400 years ago, he saw what he described as, let me try and find it. I'll find the quote later because it's absolutely, yeah, here it is. 3 fixed stars totally invisible by their smallness. What a fantastic quote that is. What he was meaning is that they weren't invisible in his telescope, because obviously he was looking at them and drawing them. But he meant that normally if you looked at Jupiter with your naked eyes, they were invisible. In fact, you can't see them with a naked eye, primarily because Jupiter's so bright, and they're so close to the planet that with naked eyes it merges into a single blob. But you don't need very much magnification. His first telescope, I believe, that he made in 1609, only had a magnification of something like 3 times. But anyway, this is what he observed. And at first he thought that he found 3 stars, but he went back, and you can see on this sketch that we're looking at, he drew it the next night. What he was expecting to find was that he thought these were 3 stars that just happened to be close to Jupiter. He was expecting Jupiter to move against the background stars, but what he saw the following night was these things had moved with it. And in this sketch you can see that he only saw 2. So this really made the poor guy scratch his head. What on earth has he found here? They're not stars. And don't forget that this is at a time when the Aristotelian physics and cosmology of the geocentric, all these fancy words just basically meaning everybody thought that the Earth was the center of the universe. They also thought, Ptolemy thought, that the heavens were fixed and other bodies other than the Earth were perfect. So that's the kind of environment that he found himself in. Now, of course, Copernicus had already come along, and he had challenged these ideas in the 16th century. And it was, coming up around this time. It wasn't far off. Kind of in 1610s, 1616, the attacks on Copernicus's contrary theory of a a heliocentric. That's where the sun is at the center of certainly our solar system, but they thought the universe as well. That was coming under increasing criticism and skepticism, and mainly, you have to say, unfortunately, through the church. Not unfortunately, it was, gosh, I often think to myself, if the Inquisitions and the church hadn't been around, how much quicker the Enlightenment would have happened. But that's probably too big a subject for tonight. But anyway, so this is the environment that Galileo found himself in, and in fact later on he was told very firmly by the church that he must not support the Copernican theories of the sun being at the center of the universe and the center of the solar system. So Galileo spots Jupiter, sees these tiny stars not moving with the stars but moving with Jupiter. He carries on going day after day, and he did this for about 10 days until in the end, actually, he also discovered that there was a fourth object as well. And by this time he worked out that these things were orbiting Jupiter. Now imagine what goes through his head. The church is saying very firmly that no one should challenge the Aristotle physics of the Earth being at the center of a perfect universe, and all other objects were perfect. And suddenly he found a body in the solar system, and he was observing it, and he saw that it was the center of other bodies orbiting around it. So Galileo was not afraid of having a bit of an argument, and he certainly rose to the challenge on this occasion. And only in March, so these drawings, these sketches are done in January, early January. In March, he publishes what's the translation is a starry messenger. So he publishes this small book. It's called Sidereus Nuncius, which is starry message. And in that book, he publishes a couple of things. One, he publishes the discovery of what he called, I think it was the Medicean moons, and that was from somebody who later became his patron, forgotten the name. I can't say it, sorry. It's late here, it's 3:30 here, so I've got an excuse. So anyway, in March, so just a couple of months after he's made these first observations of these objects orbiting Jupiter, he publishes this book in 1610, and not only does it have these observations in it, but also before Galileo turned his telescope to Jupiter, he'd been looking at the moon. And although he wasn't the first person, it was an English chap actually who first turned what he called his perspective tube to observe the moon. I think that was Thomas Harriot, and that was in the year before. This is 1609, so 4 months before Galileo looked at the moon. But Galileo was the person who could understand these features on the moon and what they were seeing, and translated into it being mountains and craters and ridges and valleys. So this also, that in a way was a bigger challenge to this Aristotelian physics, because it was showing that the moon wasn't this perfect body that those theories said it should be. So it wasn't, we mustn't overstate that, Galileo finding moons orbiting Jupiter kind of overturned this and was the thing that proved Copernicus. It wasn't. But in fact, there's another thing as well, which I'll talk about in a sec, that was really one of the final nails in the coffin, or certainly a large piece of evidence that Galileo put forward, which went on to prove or help prove Copernican theory that the sun was at the center of our solar system. Actually, I'll say it now. It was the phases of Venus. Galileo, later on this year, 1610 was an incredibly busy year for this guy. I don't know how he had time to do anything. So he's been building telescopes, he's been viewing the moon and finding out that there are mountains, ridges and all sorts of things on the moon. there are, then he goes on to discover these 4 large moons orbiting another planet. And then he goes on in September 1610 to look at Venus. And what he sees with Venus, and actually if you're a Slooh member, just recently over the last 6 weeks or so, at the end of the night every morning I've been scheduling a couple of Venus missions. So we've been watching its phase. Venus and Mercury have phases because they're between us and the Sun. So as they orbit the Sun, they exhibit a different phase like the Moon does. And this is what Galileo spotted. Now, although that doesn't kind of seem that important, what it went on to prove very clearly was that it was at total odds to Ptolemy, Aristotle, and everything orbiting around the Earth. If Venus orbited around the Earth with the Sun, then you'd only see a couple of phases of Venus. But what Galileo saw was a full range of phases, and he also saw the planet getting larger and smaller as those phases changed. So it was very obvious then that Venus wasn't, as previously thought, actually in an orbit between the Sun and Earth, so its entire orbit was between the Sun and the Earth, but actually was orbiting the Sun. So all of these things start really building up this picture that Aristotle and Ptolemy may have got it a bit wrong. So I'm going to go back now and we'll have a look at a few more images, because I don't even know whether whether the clouds have rolled in. I put a little image in there. You'll just see that, sharing it in the Hangout, and you can see it if you're on the Slooh homepage, facing the Inquisition. Goodness me, I don't know, the church's got a lot to answer for, hasn't it? That poor man was under house arrest and told that he was in threat of heresy, I think they put it, vehemently suspected of heresy, and put under house arrest until he died in 1642. What more could that man have done if he had been allowed to continue? He did write a fantastic book, actually. It's thought to be his very best publication while he was under house arrest. But just think of how some of these things have held back scientific progress. So I won't go on because I'll end up offending people if I tell you what I really think. I've got a couple of nice little graphics here. The first one is showing the same graphic that I showed on the last Jupiter show. This is showing the Io size comparison. So it's showing the Earth, our Moon, and Io. And I just love these comparisons. It really puts into perspective what we see in the live views into something that a scale that we can somehow grasp. And the next one is looking at Europa, which is slightly smaller than our Moon there. It's actually, Europa is the smallest of the Galilean satellites, and I believe all 3 of the others, Callisto and Ganymede certainly are, and I believe Io are all slightly larger than our Moon. So that's something to think about. There's some Jovian features here. I've got a graphic of Jovian features. I'm going to go into that one tonight because I thought it was more interesting to maybe talk about Galileo tonight. But I have got some other Jupiter shows coming up in this month of live astronomy, and we're going to look closer at the individual features that we can see, and we'll pick a really good night for that, because to get really, really clear pictures, we're going to need a good conditions, and certainly no cloud. I'm just going to look at the all-sky camera, and you can see actually in this all-sky camera view, so this is a camera at the observatory that looks at the whole sky. So we're looking at stars there, we're looking at the Moon, which is just about to come into the field, and actually where you look where the Moon is, just to the right of that, so we're looking at the 10 o'clock position in this image, the Moon is just slightly out of the field, but the very bright dot to the right of it is Jupiter, and that's what we're looking at with the other telescopes. So I'm just going to click back, and oh, fantastic image. What a fabulous image we've got from the T2 high magnification telescope at the moment. If you're on the home page, click through to that first image, says T2 high mag telescope, and you'll see a full color image of Jupiter with Europa to the left is the dot on the left, and then on the actual face of Jupiter itself, you'll see a little black dot at 7 o'clock. That's Europa's shadow, and you can see how much that's progressed while I've been gabbling on about Galileo. So you can see just how dynamic this system is. You know, Jupiter's rotating at such a high rate. I think its day is only about 11 hours or something like that. So in the course of a half-hour show, we're seeing it rotate. We've got another barge showing, another one of those black long dots at the top. And then we've also got Io, which is just about to come out of transit. So you can see it on the right-hand side about 3:30, the 3:30 position on Jupiter. And that's a fabulous, sorry, I'm getting a bit excited here because that's actually one of the best views of a transit I've seen on our live views. It really does look fantastic, and I think it's because it's highlighted against the dark belt behind. So what we're looking at there is Io. It's that really volcanically active satellite moon, and it's bright yellow when you see images of it up close, and we're actually seeing a little bit of color on it tonight, which is pretty good. Now, one of the things I said I was going to do tonight is I was going to let the live images on the home page run all night, in other words until dawn. Now, we don't usually do that because, you know, to look at live images on Slooh normally and to use the telescopes, you normally have to buy a subscription. But with the transits going on, I knew that you wouldn't want to necessarily listen to me for longer than half an hour, which is just about up at the moment. So I decided, and I had a quick word with Pat. In fact, I didn't really. I just went ahead and did it. I'm going to let these images, these live images of Jupiter, run on the home page, so everybody can see it free until dawn. Now, the cloud might come over. It might spoil the views, but let's give it a go. So when I finally shut up and leave you in the Hangout, you can carry on watching the Slooh homepage and carry on watching this progression of Io, and we're just seeing it now. The next image is coming in live. Io is just exiting its transit on the right-hand side of the planet. The Europa's shadow at the 7 o'clock position is moving further and further across, and then a little bit later on, if you come back and watch it, carry on watching, we'll see Europa start its transit across Jupiter's face as well. Oh, image has just gone into color. Considering we've got cloud and haze tonight, these are astonishing images, and if you think about what we're actually doing here, we should be amazed. What we're doing is we're all sharing this on the internet. We're all sitting at our various homes. I'm sitting on my sofa at home, and I controlled the telescopes, which are sitting 3,000 miles away on top of a volcano in the Canary Islands. And I'm controlling telescopes up there, and they're pointing so accurately, pointing more accurately than most telescopes in somebody's back garden operated manually will point. They're pointing so accurately that we're getting Jupiter nailed in these images on every single time. Those images are being processed in real time, and anybody who's tried any astronomical image processing will understand just how difficult it is to process astronomical images, even if you spend hours doing it. Well, this is happening in real time at the observatory. Those finished images get blasted over straight to the servers in America, in New York, and then fed out into what we see now on the home page, which is our free event viewer, but usually that pipes through straight to what we call the mission interface, which is how Slooh members watch their own missions. When they've controlled the telescopes, they watch those images coming in. So I think that's all pretty amazing stuff, and I must say there's an awful lot that you have to do to set up these Hangouts when you've got different feeds coming in and stuff like that, and it has been a little bit difficult to do on my own tonight, but I think it's been worthwhile persevering. That's assuming, of course, that everybody's heard me. You may not have heard me at all. I may have been talking to myself for the last 35 minutes, but anyway, I'm sure no one will mind that. Have a look on the home page. You'll see that we've got some other events coming up. The next one I'm going to do flying on my own again tomorrow night, on Sunday night. We're looking at the Great Globular Cluster, the Hercules Cluster M13. This is what Bob Berman, one of our regular hosts at Slooh, calls a city of stars. and you'll see why tomorrow when we look at the live images. It's going to go back to just a quick 20-minute show tomorrow night on a Sunday night, so don't worry about being late to bed, and well, it's going to be at the earlier time as well. So have a look on the homepage because it will tell you the local times, and I'll spread the word on Google Plus tomorrow and on the Slooh Facebook group, and we'll Twitter out the times of that as well. But it's going to be 23 UTC, so it's going to be the same time as all of our main events that we're doing at the moment. This one had to be at this time of night because we had to wait for Jupiter to rise and get to an altitude. And don't forget that we're looking at these images at the moment and it's still pretty low. I'm just going to have a look to see how low it is still. It's probably no more than, it's 30 degrees in the sky. So don't forget that as the night goes on, I'm going to continue these live images coming free into the home page so you can carry on watching it. It's going to be getting higher and higher. Yeah, it's 32 degrees at the moment. It's going to get higher and higher and higher until by dawn it will be at around, what are we looking at? It's going to be 75 degrees in altitude. So it's going to be, the telescope's going to be looking through less atmosphere, which for planetary imaging is incredibly important, because that's why high altitude observatory sites are really important, because we're basically getting above 8,000 feet of air, and all of that lower air is turbulent, it's hot, and it basically shakes the image when you look at a planet. And if you look through a telescope, when you do look through a telescope at Jupiter, you'll see it shaking around all over the place. You won't get a clear image like this. You know, this is because we're taking an image with CCD cameras and stuff like that. But anyway, the image quality that will appear on the home page tonight will just carry on improving and improving as Jupiter rises higher in the sky. That is, as long as the clouds stay away. Now, I'm just going to, normal Slooh members can always check the sky conditions, but if you're on the home page tonight, if you go through, you'll still be able to see the wide field view as well, so you'll be able to see the small white dots as Galileo saw them moving almost in real time. If you keep watching, you'll suddenly see one disappear and you'll see one coming out the other side. It's fabulous to look at. But if you click through and go to what we call the all-sky camera, so if some of the Jupiter images start looking a bit odd, check the all-sky camera out, and don't forget it's around the 10 o'clock position. It's going to kind of continue to the center of the image as the night goes on. If you might see light cloud or haze, which would be causing that problem. I'll try and keep an eye on things. If it does get too bad, I'll probably switch it off. But we'll try and persevere, because I hope you'll enjoy watching what I think is one of the most enjoyable and dynamic objects to look at in the night sky. And it doesn't really matter whether you're looking at it through a cheap pair of binoculars or watching it through an observatory which houses literally hundreds of thousands of dollars worth of equipment. The equipment that's necessary to do this kind of thing automatically is very advanced, and it's pretty expensive. But you can control it. You can control this stuff. You can either join Slooh and control these telescopes yourself. And just in passing, I'm going to finish up now, because I'm sure you all want to go to bed and stop listening to me rabbiting on about Galileo and my mispronunciation of lots of strange names. Fortunately, I'm not proud. I am really. Before I go, I'm just going to ask you one more time, please, if you enjoy what Slooh does, if you want to support our free broadcasts like this, if you want to use these telescopes with a single click from your mobile devices, please help us in the development of our app that we're currently in the middle of. Go to the MySky campaign site. That's www.slooh.com/MySky. The MySky is this mobile app that's going to allow anybody to single click control these telescopes that are taking these live images tonight, and the same telescopes that we're going to be using in this entire month of live astronomy shows. So I hope you enjoy it. If you do, if you put some value on that, if you want to help spread the word of looking at stuff like this rather than looking at Grand Theft Auto. Come on, let's get kids doing something better with their computers and stuff like that, because we can turn this stuff into being an exciting pastime for them. Don't forget though, the Slooh telescopes, they're as easy to control for a kid, but also some of our members are using it for some fantastic scientific pursuits as well. We've got people contributing at the moment to near-Earth asteroid orbits. So when these things are first discovered, the astronomers don't know its exact orbit. So some of our members are actually making follow-up observations and submitting those to the Minor Planet Center. And Norm, one of our dearest members, is doing some absolutely fantastic work with that. And he actually contributed to determining the orbit of a potentially hazardous asteroid, which was only discovered on the 26th of August, so a week or so ago, a couple of weeks ago. And it's making its closest path to Earth this coming Thursday night. So on the night of the 13th and 14th, Slooh, here, me, we're going to be providing live views of this potentially hazardous asteroid as it whizzes past Earth. Now, don't get too excited. We're not going to see a large lump of rock. We're going to see this asteroid as a streaking point of light against the background stars, but it's still going to be fascinating to watch this thing that was only discovered such a short time ago, and only a short time before its closest approach to Earth. And I think that's the important thing that I always think. It's not going to hit Earth, so we haven't got to worry about that. It's far enough away. But these things are still being discovered only days before they make their closest path to Earth. So I think that's the interesting thing about that. So please join us. If you don't join us for our other nightly shows that we're doing, then please join us on Thursday night for that, because that's bound to be an exciting show. We'll have some wonderful guests. I suspect we may have Bob Berman hosting the shows as well. We may have Duncan Kopp and some of our other regular guests as well. I probably won't be on the actual show because I'll be busy taking images using the half-meter telescope, and that's quite an intense process as this thing whizzes across the sky. But I'll be here, other than that, every single night. I'll be here tomorrow night to see the Hercules, the great globular cluster, this city of stars, as Bob Berman refers to them. And don't forget, you can carry on watching these live views tonight of Jupiter and its moons Europa and Io as they transit across the face of Jupiter. And have a think about Galileo when you see the wide field view tonight, and imagine him 400 years ago looking at that and scratching his head thinking, what on earth am I seeing for the first time? It's fantastic. I hope you enjoy astronomy as much as we do. Please support us if you do. This is Paul Cox signing off for Slooh. Good night, everybody.